Hey guys, hoping all is well with everyone. So in our question of the day today, we're going to be looking at a question revolving around 8th grade level math that looks into the concepts and topics of solving exponential equations with the applications of laws of exponents and properties of exponents as well. So here in our question, we're asked to solve for x in the equation that 64 to the 3x plus thirds power is equal to 4 to the 3x minus thirds power. And I started things off just by kind of rewriting our equation here. So when we look at an equation like this, there are multiple ways to approach this, but the biggest goal from the get-go is to somehow use some algebraic manipulation to make the bases identical to each other. So the way that we're going to do that is by using some critical thinking and asking ourselves, what kind of relationship do 4 and 64 have in common? Well, there's a couple ways that you can think about it, but if we look at our idea of our perfect cubes, we have that 64 is a perfect cube of 4. So we're going to use that to represent 64 as 4 cubed. Now, because I'm doing that, what this is going to do is I'm going to be representing a power and taking it to a power. So this is going to lead us to a situation where we're going to have to use the power to power rule, which means that if I have two exponents and they are being taken to each other, or a exponent is being taken to another exponent, I'm going to have to multiply them. So I'm going to have to use distributive property here in the next step. Now on the right side, I'm not going to change anything because 4 is the base that I have decided to go with. So I don't have to change the right side of the equation in any way because I've done the algebraic manipulation and changing of the present form of it to a more desirable appearance. So what I'm going to do now in this next step is I'm going to represent this left side as a product of the two exponents because of that power to power rule. So what's going to happen in the next step is that distribution property. But again, I'm going to go ahead and leave the right side the same. And as you can see, now we have done that big task of representing the left side to an identical base on the right, and that's going to be extremely helpful in just a moment. So we have this next step where we'll go ahead and perform the distribution. So we're going to do 3 distributed into 3x, which is going to give us 4 to the 9x. And then 3 distributed into 3 is 9 as well. And then again, we're not going to change anything with the right side. And what this now does is it allows us this unique opportunity to be able to represent our original equation of 64 to the 3x plus 3 equals to 4 to the 3x minus 3 as an equation of the exponents themselves. So this is going to provide for us a double-sided variable equation of the exponents. So this is going to be that 9x plus 9 is equal to 3x minus 3. Okay, so now that we have come to a situation in that we have a single variable on both sides, we're going to now solve this equation with that idea of our balance scale. So anything that I want to do to be able to isolate the variable or go towards its value, I have to apply the operation to both sides. So I'm going to start things off by subtracting 3x from both sides. So these 3x's will cancel out. 9x minus 3x is 6x. And I get that 6x, bring down the 9, is equal to negative 3. And then my next step is to isolate x further. I'm going to subtract 9 from both sides. And then just here we want to be careful with your subtraction of negative numbers here, but we're going to get that 6x is equal to negative 12. And then my last step to fully isolate x and get it up by itself, I'm going to go ahead and divide both sides by 6. And then we have that x is equal to negative 12 over 6, which is going to be giving us the value of negative 2. So that will be our final answer. Okay. Now, again, as I mentioned, there's another way that you can approach this. I'm not going to go into the step-by-steps with this one, but just kind of walking you through it. Instead of representing the left side as 4 cubed to the 3x plus 3, another option that you have is to keep the left side the same and represent it as 64 to the 3x plus 3. And then what you can do is represent the right side is equal to a base of 64 to the 1/3 power. And the reason for that is because 4 is equal to the cubic root of 64. But this would just, the only difference is that you would now be using more of a fractional exponent approach. But then you can still use this idea of distributive property, and then you can solve for x like that. Okay, and then this one, this would be that, I'll go ahead through the steps here and just kind of make it a little bit more divided. There we go. So 3x plus 3, and then you distribute the 1/3 into 3x minus 3, so that's going to be that 1/3 times 3x is just x. And then 1/3 minus, or 1/3 times 3 is 1, so that's going to be x minus 1. And then we go ahead and we solve, so we're going to go ahead and first subtract x from both sides. Remember that that coefficient understood on x, even though it doesn't have one, is that understood 1. So we can go ahead and subtract 1x from both sides. We'll get that 2x plus 3 equals negative 1. We'll then isolate x further by subtracting 3 from both sides. The plus 3 minus 3 will cancel themselves out. We get 2x is equal to negative 4. And then we take our final step of finaling the isolation of x by dividing by 2, and we get that x is equal to negative 2. Okay, so as you can see, multiple ways to represent it as the same base, but the next step, or the next kind of method I wanted to show you is representing these bases that are not either of each other. So it's going to be a base that both are relative to each other by exponents, and that's going to be a base of 2. So let's go ahead and kind of clean things up a bit here. Just let me click erase here. So as I mentioned, for this one, we're going to be approaching this as this is a base of 2. So the way that we're going to do this here is 64 is 2 to the 6th power. So we can use that information. And again, that is a perfect to the 6th power. So I'm going to represent 64 as 2 to the 6th, because 2 to the 6th power is 64. So you have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this is going to be representative of 2 to the 6th. And I'm going to have to use that distribution again, but that's okay. And then I'm going to represent 4 as 2 squared. Okay. But again, I'm going to have to do this now on both sides, and that's okay. This is all going to still turn out very clean. It's still going to give us this same resultant, but as you can see through all 3 methods, we're just coming up with a different double-sided variable equation each time. So if I go ahead now and I do my distribution on the left side, it's going to be 2, and then 6 times 3x is 18x, and then 6 times 3 is 18, so we have 2 to the 18x plus 18. And then this is going to be equal to 2. And then 2 times 3x is going to be 6x. And then 2 times 3 is 6, so 6x minus 6. So now we have that unique opportunity to allow the exponents to be representing this equation in and out of itself. So now that the bases are identical, we can represent this original equation as 18x plus 18 is going to be equal to 6x minus 6. So we'll start things off. We're going to subtract 6x from both sides. On the right side, the 6x minus 6x will cancel. We want that to happen. 18x minus 6x is going to give us 12x. We're going to bring down the 18 because it's still part of the equation. We're going to go ahead and bring that negative 6 as the remainder on the right side. And then we will subtract 18 from both sides. Again, just being careful with your subtraction of negative numbers here. So this is going to cancel out on the left. We're going to get that 12x is equal to negative 6 minus 18 is negative 24. Finalize my solving of x by dividing both sides by 12. And x is going to be equal to negative 24 over 12, equaling negative 2. So as you can see, there's a lot of different paths that you can take with solving these types of questions. But again, the moral of the story in terms of the main goal to start things off is to just represent or algebraically manipulate the equation to where the bases are identical. Sometimes you may just have to manipulate one side of the equation, and in other times, if it's easier or more comfortable, you can manipulate both sides algebraically. But I hope this helps you guys out. If you have any questions or if you have any other methods that you've taken that you have found helpful or very strategic, please let me know. But I hope you guys have a wonderful rest of your day. Thank you so much for watching. And as always, take good care and be safe. Bye.